Mapua University is one of the top universities in the Philippines, with a wide range of offered programs, especially in the field of engineering and sciences.
The School of Chemical, Biological, and Materials, Engineering and Sciences is a huge contributor of published research in the university.
Material Science and Engineering program focuses its research in areas about polymers, membrane, energy, and nanotechnology.
As a material science and engineering student, we dedicated our research in fabricating polymer membranes entitled Thin Film Fabrication and Characterization of PVDF MOF membrane with woven support via NIPS for Lemon Juice Microfiltration. I, Mikhail M. Brillantes, together with
Narc Mikhail A. Gañac and our advisor, Dr. Alvin R. Caparanga. The membrane was composed of the polymer polyvinylidene fluoride or PVDF, metal organic framework or MOF as the additive material, N-methyl-2-pyrrolidine or NMP as the solvent in which the solution is subjected into the non-induced phase separation or NIPS, together with a woven support.
PVDF is hydrophobic in nature, though the study needs to produce a hydrophilic membrane for filtration. A solvent that is naturally hydrophilic, known as NMP, is added to form the solution. The study is divided into two parameters, the ones containing the MOF and the others without the additive. Each parameter is then divided into three concentrations at 15% weight, 20% weight, and 25% weight of PVDF.
After the fabrication and storage of the membranes, produced the second part of the study is to characterize the samples testing in its mechanical strength through the use of the Universal Testing Machine or UTM, its surface morphology using the Scanning Electron Microscope or SEM, its contact angle and wettability with the contact angle goniometer, the pore size and pore size distribution with the porometer to obtain its internal and surface properties.
The next part of the experimentation is testing the membrane's performance when it undergoes microfiltration. The permeate flux and the rejection ratio were determined with the help of the lemon juice as the substance of the process.
Analyzing the results that we obtained during characterizations showed that with the SEM images obtained at 10 kilovolts using 30x magnification with secondary electrons, the membrane of 25% weight PVDF and 0.1 MOF obtained the best surface morphology, showing small sizes of pores and how they are distributed across the membrane.
This was complemented by the results from the porometer, where the same membrane produced the smallest range of pore sizes at 0.214 to 0.697 micrometers at 0 to 3 bar. Furthermore, the property was thoroughly tested using a syringe filter setup to acquire the permeate flux of the microfiltration process. The same 25% weight PVDF and 0.1% MOF stood out of the membrane performance testing, showing a 3.05 times 10 raised to 3 milliliter per millimeter squared second at a higher pressure of 3 to 6 bar.
In order to obtain the rejection factor of the membrane's performance, we used an equipment called the Atago refractometer that measures the sugar concentration of bricks of the permeate and the retentate. At 3 trials, each setup, the mean rejection ratio that prevailed was at 9.5238% for the 25% weight PVDF and 0.1% MOF. The hydrophobic property of each membrane decreases as the concentration of the PVDF increases due to the viscosity of the solution, although every sample stayed hydrophilic. The tensile strength of the materials showed an increase in value due to the addition of the woven support with 20% weight PVDF and 0.1% MOF, earned a 67.86 MPa.
Fabrication of PVDF and PVDF plus 0.1% MOF membranes dissolve in NMP with varying concentrations of PVDF, 15% weight, 20% weight, and 25% weight. Via NIPS was a success. Every step of the fabrication is crucial, especially after the sonication and precipitation process of the solution. At higher concentration, with high viscosity of the solution, alters the performance of the membranes, but with the addition of MOF that makes it more porous, resulted into a better property that reflects on the SEM and porosity characterization. The phase inversion process is also a huge factor that could cause warps on the membrane if not accounted for.
We recommend to use a wider range of concentration, altering the PVDF and 0.1 weight MOF. An advisable setup to use is a hot bath during the heating of the solution, rather than the direct heat from the hot plate, so that the temperature is controlled in the heating solution. Membrane fouling is also an issue that should be controlled, although it is not included in the scope of our study. Modification of the hydrophilicity of the membrane could help the reduction of antifouling. Instances, it is by changing the solvent with a higher philicity nature. Material science and engineering is a growing industry that focuses on the improvement of our daily lives.
We should continue to explore, create innovations, and share these ideas to the world.
Once again, I'm Narc Mikhail A. Gañac.
And I am Mikhail M. Brillantes. Material Science and Engineering, Mapua University.